Artificial intelligence is shaping the world around us. From hiring decisions to loan approvals, from healthcare diagnostics to content moderation, AI is making choices that impact lives. But beneath the surface of these advancements lies a fundamental challenge, one that goes beyond just efficiency and accuracy. AI has the power to amplify bias just as easily as it can drive innovation. Imagine an AI system designed to help companies identify top talent. It scans thousands of resumes, searching for the best candidates. But if the data it was trained on reflects decades of systemic bias, the AI will unknowingly favor certain groups while excluding others. A credit scoring model that aims to predict financial reliability might unknowingly penalize entire communities simply because historical data contains inequalities. This is the dilemma at the heart of AI, the constant balancing act between performance and fairness. Accuracy alone is not enough. Without fairness, AI risks reinforcing the very problems it was designed to solve. The question is, how do we ensure that AI systems don't just work well, but work fairly? Today, we explore the risks, the challenges, and the solutions. We'll look at how fairness can be embedded into AI, how data quality and transparency shape outcomes, and why accountability is no longer optional. AI must be built on trust, and trust begins with responsible design. This conversation isn't just about compliance or regulation. It's about the future of technology and its impact on society. If AI is going to be a force for good, fairness has to be part of its foundation. Artificial intelligence has transformed how we solve problems, enabling innovations that were unimaginable a few decades ago. From automating routine tasks to making complex decisions, AI's potential seems limitless. But with great potential comes a critical responsibility, ensuring that these systems operate ethically, transparently, and reliably. This is where the concept of trustworthy AI comes in. It isn't just about creating systems that work. It's about creating systems that earn and maintain trust. The slide emphasizes the importance of trustworthiness in AI, noting that it is critical for the successful deployment of AI applications. Trustworthiness is about ensuring that these systems operate not just efficiently, but also ethically. This has become even more crucial with the rise of regulatory frameworks like the European AI regulation, which prioritize accountability and transparency in AI systems. Without trust, AI adoption becomes a risk rather than a reward. But what exactly does trustworthiness in AI mean? It's about ensuring that AI systems can be relied upon to make fair and transparent decisions. It's about creating systems that comply with ethical standards and are free from harmful biases. And it's about giving users the confidence that AI is not just a black box making unexplained decisions, but a tool they can understand and trust. The second key point on the slide introduces foundation models as the backbone of many AI applications. These models provide pre-trained systems that can be fine-tuned for specific tasks, making AI development faster and more efficient. However, foundation models also introduce unique risks. They are trained on massive datasets, which often include biases or inaccuracies. Without careful assessment, these biases can propagate in AI applications, undermining trustworthiness. The slide also highlights the objectives of the white paper it introduces. These objectives are clear: to create a framework for assessing and ensuring the trustworthiness of AI applications that are built on foundation models. This framework takes a risk-based approach, addressing potential issues at every stage of the AI lifecycle, from data collection and model training to deployment and monitoring. Why is this framework so important? It acknowledges that while AI has the potential to create transformative solutions, it also comes with inherent risks. Without proper safeguards, AI applications can perpetuate inequality, spread misinformation, or make unreliable decisions. By offering guidelines to identify and mitigate these risks, the framework ensures that AI systems are not only effective, but also aligned with ethical standards. In a world where AI decisions impact hiring, healthcare, finance, and more, the stakes for getting it right are high. Trustworthiness is not an afterthought, it's a necessity. Users must feel confident that AI systems will not only perform as intended, but also operate within ethical and transparent boundaries. Regulators, developers, and organizations all play a role in this, ensuring that trustworthiness is built into every stage of AI development. This introductory slide sets the stage for a deeper exploration of how trust can be built into AI systems. It challenges us to go beyond innovation and think critically about accountability, transparency, and fairness. The goal is clear: to create AI systems that not only solve problems, but do so in a way that benefits everyone. Artificial intelligence has advanced in leaps and bounds, and at the heart of these breakthroughs lie foundation models, a new frontier in AI development. These models are transformative because they represent a significant shift in how AI systems are built and applied across industries. Foundation models are advanced, pre-trained AI systems that serve as versatile bases for creating specialized applications, offering a level of efficiency and adaptability that traditional models cannot match. The slide begins with a definition and purpose. Foundation models are trained on vast multimodal datasets, enabling them to handle a wide range of tasks with minimal fine-tuning. Imagine a single model that can power chatbots, generate realistic images, and even summarize lengthy documents, all without the need for extensive retraining. This versatility is why foundation models have become a cornerstone of AI development. They provide a starting point for innovation, reducing time and resource requirements for creating specialized AI applications. A critical point highlighted is the technical construction of these models. Foundation models utilize self-supervised learning, a revolutionary technique that allows them to train on unlabeled datasets. In traditional AI, training requires extensive labeled data, which is often costly and time-consuming to produce. But foundation models learn by generating their own labels from the input data, uncovering patterns, relationships, and correlations without the need for manual intervention. This approach enhances their adaptability and broadens their utility across diverse applications. Another defining characteristic is their ability to perform multitask learning. Unlike conventional AI models designed for narrow, single-purpose tasks, foundation models are capable of handling multiple tasks simultaneously. For example, a foundation model could power a voice assistant that not only understands spoken commands, but also provides detailed explanations for its actions. This ability to deliver both output and context significantly improves user comprehensibility and trust. The slide also contrasts foundation models with traditional AI systems. While conventional models rely heavily on large quantities of labeled data and are tailored for specific tasks, foundation models are inherently more flexible and efficient. They leverage their generalized pre-training to excel at tasks with much smaller datasets. This distinction is crucial for understanding why foundation models are reshaping the AI landscape. They enable faster, more scalable development without compromising performance. Finally, the slide touches on the economic and societal impact of these models. Foundation models not only reduce the resources required to develop AI systems, but also democratize access to advanced AI capabilities. Startups and smaller organizations which might not have the resources to train their own models from scratch can now build powerful applications by fine-tuning these pre-trained systems. This opens the door to innovations in areas like healthcare, education, and sustainability, where AI can make a significant difference. However, as we celebrate these advancements, we must also recognize the challenges that come with them. The datasets used to train foundation models often contain inherent biases, and their decisions can lack transparency due to their complexity. These issues underline the importance of ensuring that foundation models are developed, deployed, and monitored responsibly. Understanding foundation models is key to grasping how modern AI systems are evolving. They are powerful tools, but like all tools, their impact depends on how they are used. By exploring their construction, applications, and societal implications, we can harness their potential while addressing the risks they introduce. This understanding forms the foundation, both literally and figuratively, for building trustworthy AI. Foundation models have transformed the way artificial intelligence is built and deployed, but their true power comes from how they are trained and fine-tuned for specific applications. Training a foundation model is not a simple process. It's a journey that begins with data collection, evolves through self-supervised learning, and culminates in fine-tuning. Each step is critical to ensuring that the model is not only effective, but also trustworthy and aligned with its intended purpose. The first step is data collection, as highlighted on the slide. The foundation of any model, quite literally, is the quality and diversity of the data it is trained on. To build a robust foundation model, developers must gather extensive datasets that are relevant to the target application. For example, an AI system designed for healthcare diagnostics requires data that reflects a wide range of medical conditions, demographics, and scenarios. The goal is to ensure that the model can generalize its learning across different inputs, minimizing the risk of bias or blind spots. Poor quality or unrepresentative data can cripple a model's reliability, leading to flawed outcomes that undermine trust. Once the data is collected, the next phase is self-supervised learning. This revolutionary approach allows the model to train on unlabeled data, dramatically reducing the reliance on costly and time-intensive human annotations. Through self-supervised learning, the model identifies patterns, relationships, and correlations within the data. For example, it might predict missing words in a sentence or learn how objects in an image relate to one another. This stage is where the model develops its foundational knowledge, enabling it to perform a wide range of tasks. However, this also introduces risks. If the underlying data contains biases or inaccuracies, the model will internalize and replicate them, potentially scaling those issues across all its applications. The final stage is fine-tuning, where the foundation model is adapted for specific tasks or industries. Fine-tuning involves using smaller application-specific datasets to refine the model's performance for its intended purpose. For instance, while a general-purpose language model might excel at natural language understanding, fine-tuning it with customer service data enables it to provide personalized, context-aware support to users. This process ensures that the model leverages its broad, pre-trained capabilities while aligning with the nuances of a specific domain. Fine-tuning is where trustworthiness becomes especially important. Without careful oversight, the model's outputs could still reflect unintended biases or inaccuracies inherited from its initial training. Developers must rigorously test the fine-tuned model to ensure it meets ethical and performance standards. This might include fairness audits, transparency evaluations, and continuous monitoring during real-world deployment. The slide underscores that each phase, data collection, self-supervised learning, and fine-tuning, must be approached with care and precision to build models that are both effective and responsible. Beyond the technical process, this training pipeline has profound implications for the ethical and practical use of AI. By focusing on high-quality data and targeted fine-tuning, we can create models that address real-world challenges without compromising fairness or transparency. This is particularly critical in applications like hiring, healthcare, and criminal justice, where the consequences of biased or unreliable AI decisions can be severe. In summary, training and fine-tuning foundation models is about more than just achieving technical excellence. It's about embedding trust into the very fabric of these systems, ensuring that they are not only capable, but also reliable, ethical, and aligned with the values of the society they serve. By understanding and refining this process, we can harness the full potential of foundation models while minimizing the risks they pose. Foundation models have opened the door to a new era of artificial intelligence where their versatility and power enable applications that were once considered out of reach. The process of developing AI applications with these models is transformative, offering developers tools to solve complex problems across industries. However, the success of these applications hinges on the strategies used to adapt and guide foundation models, especially techniques like zero-shot learning and few-shot learning. The slide focuses on these advanced methods, starting with zero-shot learning. This approach allows foundation models to perform tasks they have never been explicitly trained on. By relying on semantic embeddings, zero-shot learning enables the model to generalize its understanding across tasks. For instance, imagine an AI system tasked with summarizing legal documents. Even if the model has not seen this specific task before, it can rely on its pre-trained knowledge of language structures and relationships to provide meaningful summaries. The effectiveness of zero-shot learning is remarkable, but it relies heavily on well-crafted prompts, a technique known as prompt engineering. Prompt engineering is a critical aspect of application development with foundation models. It involves carefully designing inputs to guide the model's behavior and ensure high-quality outputs. In the legal document example, the prompt might specify the type of summary required, whether it should focus on key rulings, procedural details, or broader implications. The quality of these prompts determines whether the model delivers useful, context-appropriate results or falls short of expectations. The slide also highlights few-shot learning, another powerful technique. Unlike zero-shot learning, few-shot learning involves providing the model with a small number of examples to help it understand a specific task. For instance, to train a customer service chatbot, developers might provide a handful of sample queries and responses to fine-tune the model's understanding of conversational nuances. This approach combines the efficiency of foundation models with the specificity needed for targeted applications, making it ideal for domains where labeled data is scarce. Both zero-shot and few-shot learning showcase the adaptability of foundation models, but they also reveal the challenges inherent in working with these systems. While foundation models are incredibly powerful, their outputs can vary significantly depending on how they are guided. Poorly designed prompts or insufficient examples can lead to errors, biases, or irrelevant results. This is why developers must approach application development with a deep understanding of the model's capabilities and limitations. Moreover, the slide underscores that foundation models are not just technical tools, they are strategic assets with broad implications. Their ability to generalize across tasks makes them invaluable in fields like healthcare, where they can assist with diagnostics, or education, where they can create personalized learning experiences. However, with this power comes a responsibility to ensure that applications are developed ethically and responsibly. Issues like transparency, fairness, and accountability must be central to the development process. In summary, application development with foundation models is about harnessing their flexibility and power to solve real-world problems. Techniques like zero-shot and few-shot learning enable developers to unlock new possibilities, but they require careful planning and ethical oversight. By understanding the intricacies of these models and applying them thoughtfully, we can create AI applications that are not only effective, but also trustworthy and aligned with societal values. Foundation models are the backbone of modern AI systems, providing unprecedented capabilities and efficiency. However, with great power comes great responsibility, and these models are not without their risks. Slide 5 highlights 4 key areas of concern: fairness, reliability, transparency, and data protection, all of which pose significant challenges to the trustworthiness of AI applications built on these models. Addressing these risks is critical to ensuring that foundation models are used ethically and responsibly. Let's start with fairness, which is one of the most pressing risks. Foundation models are trained on vast datasets, often sourced from the internet or other large-scale repositories. While these datasets allow for broad generalization, they also come with embedded biases reflecting historical inequalities, stereotypes, or skewed representations. For example, if an AI system is trained on biased hiring data, it might unintentionally favor certain demographics over others. This can lead to discriminatory outcomes, reducing the quality of services for underrepresented groups. Ensuring fairness requires thorough testing at the application level to detect and mitigate these biases before they impact real-world decisions. Reliability is another critical challenge. Foundation models can suffer from issues such as outdated training data or hallucinated outputs. Outdated data limits the model's ability to make accurate predictions in a rapidly changing world, while hallucinations, when the model generates information that appears plausible but is factually incorrect, can erode user trust. For example, an AI-powered healthcare assistant might provide inaccurate medical advice based on incomplete or old data, putting patient safety at risk. Continuous monitoring and updates are necessary to ensure that foundation models remain reliable over time. Transparency, or the lack thereof, is a fundamental issue with foundation models. These models are incredibly complex, often operating as black boxes that make decisions without clear explanations. For end users, this lack of transparency can be problematic. How does a foundation model decide who qualifies for a loan or who gets shortlisted for a job? If users cannot understand or challenge these decisions, trust in AI systems diminishes. Regulatory frameworks now demand clearer documentation and increased user awareness to address these concerns, emphasizing the importance of making AI systems interpretable. Finally, the slide addresses data protection, an area fraught with legal and ethical challenges. Foundation models can inadvertently expose sensitive information through model inversion attacks, where adversaries extract details from the training data. Additionally, the use of copyrighted or legally protected content in training datasets raises questions about intellectual property rights. Organizations must adopt robust data management practices to mitigate these risks, ensuring compliance with privacy laws and ethical standards. Each of these risks, fairness, reliability, transparency, and data protection, represents a potential vulnerability in the deployment of foundation models. Left unaddressed, these risks can lead to significant consequences, from legal penalties to loss of public trust. But these challenges are not insurmountable. Developers, regulators, and organizations must work together to create safeguards at every stage of the AI lifecycle. In conclusion, the risks associated with foundation models are as significant as their benefits. By understanding and addressing these challenges, we can build systems that not only perform well, but also operate ethically and transparently. Foundation models have the potential to revolutionize industries, but their deployment must be guided by a commitment to fairness, reliability, transparency, and data protection. Trustworthy AI is not just a technical goal, it's a societal responsibility. The rapid rise of artificial intelligence has brought with it immense possibilities, but also complex risks that require thoughtful oversight. To address these challenges, governments and regulatory bodies are stepping in with the European AI regulation, also known as the EU AI Act, leading the way. As the first comprehensive legal framework for artificial intelligence in Europe, this regulation is designed to manage the risks associated with AI technologies while fostering innovation and trust. The slide introduces the core components of the regulation, beginning with its risk-based approach. Unlike previous attempts at regulating AI, which often treated all systems equally, the EU AI Act categorizes AI applications into 4 distinct risk levels: minimal, moderate, high, and unacceptable. Each category comes with its own set of compliance requirements. For instance, high-risk applications, such as those used in healthcare, hiring, or law enforcement, must undergo rigorous scrutiny to ensure safety, reliability, and fairness. This approach ensures that the level of oversight is proportional to the potential impact of the AI system. The regulation also emphasizes trustworthiness and compliance as central goals. By establishing clear guidelines for transparency, performance, and data quality, the framework seeks to create AI systems that users can rely on. Trustworthiness isn't just a technical requirement, it's about creating systems that align with ethical principles and societal expectations. For example, an AI model used for diagnosing medical conditions must not only be accurate, but also transparent in how it reaches its conclusions, ensuring that patients and healthcare providers can trust its recommendations. Another key component of the regulation is the conformity assessment process, particularly for high-risk AI applications. This involves comprehensive evaluations of AI systems to ensure they meet stringent standards of accuracy, robustness, and cybersecurity throughout their lifecycle. Providers of foundation models are also held to high standards with specific requirements to maintain transparency, manage training data effectively, and undergo conformance checks when integrated into high-risk applications. These measures are designed to promote accountability and ethical use of AI technologies. The regulation further highlights the importance of data quality management. Providers must ensure that the datasets used to train AI systems are representative, error-free, and relevant to the specific application domain. This reduces the risk of biases and inaccuracies that could undermine the fairness or reliability of the system. By holding providers accountable for their training data, the EU AI Act ensures that the foundation of every AI system is built on ethical and trustworthy principles. Beyond technical safeguards, the EU AI Act also places a strong emphasis on transparency obligations. Providers are required to disclose how their systems interact with users, document the data used in training, and ensure that AI-generated content complies with existing laws, including copyright regulations. This level of transparency is essential for building user confidence and ensuring accountability. In summary, the European AI regulation represents a groundbreaking approach to governing artificial intelligence. It acknowledges the transformative power of AI while addressing the risks it poses, particularly in high-stakes applications. By categorizing AI systems based on their risk level and enforcing stringent requirements for transparency, accountability, and data quality, the regulation provides a blueprint for building trustworthy AI. More than a legal framework, the EU AI Act is a statement of values, prioritizing fairness, safety, and ethical responsibility in the development and deployment of AI technologies. As organizations navigate this new regulatory landscape, they must recognize that compliance is not just about meeting legal requirements, it's an opportunity to build AI systems that inspire trust, deliver value, and align with the principles of fairness and accountability. The European AI regulation is not just shaping the future of AI in Europe, it is setting a global standard for how AI can be responsibly and ethically governed. Artificial intelligence is a double-edged sword. While it offers transformative possibilities, it also introduces significant risks. High-risk AI applications, such as those used in healthcare, hiring, finance, or public safety, have the potential to profoundly impact individuals and societies. To ensure these applications are trustworthy and align with ethical standards, the European AI regulation outlines specific requirements. These guidelines are designed to identify, mitigate, and manage risks throughout the lifecycle of high-risk AI systems. One of the cornerstone requirements is the establishment of a risk management system. High-risk AI systems must be developed with a comprehensive framework to identify, assess, and mitigate potential risks. This involves proactive measures to ensure safety and ethical compliance, as well as ongoing monitoring to address emerging risks. For example, an AI-powered diagnostic tool in healthcare must be constantly evaluated to ensure it delivers accurate and unbiased recommendations as medical knowledge evolves. Another critical component is data quality management. High-risk AI applications depend on data sets that are not only relevant and representative, but also free of bias and errors. Consider an AI system used for loan approvals. If the training data reflects historical discrimination, the model risks perpetuating those biases in its decisions. To address this, developers must implement measures to identify and correct biases, ensuring that the data is aligned with the specific characteristics of the application domain. This process safeguards fairness and improves the reliability of AI systems. The slide also emphasizes technical documentation, which plays a crucial role in fostering transparency and accountability. Developers of high-risk AI systems are required to maintain detailed records outlining the design, functionality, and operational procedures of their systems. This documentation must be accessible and understandable, not only for regulators but also for end users. For instance, if a law enforcement agency deploys an AI system for facial recognition, the documentation should clearly explain how the model was trained, what its limitations are, and how its decisions can be interpreted. Operational monitoring is another essential requirement. High-risk AI systems must be equipped with robust logging and monitoring mechanisms to track their behavior in real-world conditions. These tools ensure that the system operates as intended and provide a way to identify and address anomalies or failures. Human oversight is a critical aspect of operational monitoring. It ensures that AI systems remain accountable, allowing humans to intervene when necessary, and verify that the system is aligned with ethical and legal standards. The final requirement highlighted on the slide is transparency obligations. Providers of high-risk AI systems must disclose how their systems interact with users and ensure that any generated content complies with applicable laws, including copyright regulations. This includes summarizing the training data used, particularly if it includes copyrighted material, to enhance accountability and user awareness. Transparency is key to building trust. Users need to understand how AI systems make decisions and be assured that those decisions are fair and unbiased. Together, these requirements form a robust framework for ensuring that high-risk AI applications are developed and deployed responsibly. They address the full spectrum of risks, from biased training data and unreliable outputs to lack of transparency and accountability. By adhering to these guidelines, organizations can mitigate the potential harms of AI while maximizing its benefits. In conclusion, high-risk AI applications hold immense potential, but their development comes with heightened responsibilities. The requirements outlined by the European AI regulation ensure that these systems operate ethically, transparently, and reliably. Organizations must embrace these guidelines not just as regulatory obligations, but as opportunities to build AI systems that inspire trust and confidence. The stakes are high, but with the right safeguards in place, AI can be a powerful force for good. Foundation models are the driving force behind many advanced AI applications, offering unmatched versatility and scalability. However, their immense power comes with significant responsibilities. To ensure these models are developed and deployed ethically and effectively, the European AI regulation outlines a set of requirements that address their unique risks and challenges. These requirements aim to establish trustworthiness across three critical areas: general obligations, special requirements, and transparency. The general requirements emphasize the importance of transparency obligations and risk identification. Providers of foundation models are required to disclose interactions with end users and ensure that AI-generated content complies with legal standards, particularly copyright laws. This includes documenting the training data used, especially if it incorporates copyrighted material, to enhance accountability and user trust. For example, if a foundation model generates creative content such as artwork or music, the provider must clarify whether that content derives from protected sources. Transparency extends beyond legal compliance. It is fundamental to building trust. Users and regulators need to understand how these models operate, how they were trained, and how their outputs can be interpreted. This becomes especially important when foundation models are integrated into high-risk applications, where lack of clarity can lead to misunderstandings or misuse. Risk identification is another crucial element of the general requirements. High-impact foundation models must undergo thorough assessments to evaluate risks related to health, safety, fundamental rights, and societal impacts. For instance, a model used in hiring decisions must be evaluated for biases that could result in unfair treatment of certain groups. This proactive approach ensures that risks are identified and addressed before deployment, reducing the likelihood of harm. The special requirements outlined on the slide focus on performance evaluation and data quality management. Foundation models must demonstrate adequate performance across critical dimensions, including accuracy, robustness, and cybersecurity. Independent testing is required to verify these performance metrics, ensuring that the models are resilient against unauthorized manipulation and capable of delivering reliable results throughout their life cycle. For example, an AI model used in financial decision-making must be tested to ensure it operates consistently under different market conditions without generating misleading outputs. Data quality management is equally critical. Providers must ensure that the data used to train foundation models is relevant, representative, error-free, and complete. This requirement addresses one of the most significant risks associated with foundation models: the potential for biased or incomplete training data to compromise the fairness and reliability of the system. Measures must be taken to identify and correct biases in the data, particularly for applications where fairness is essential, such as healthcare or criminal justice. At the heart of these requirements is the recognition that foundation models are not merely technical tools. They are systems that shape real-world outcomes. As these models become more integrated into high-stakes domains, their risks and responsibilities grow exponentially. The guidelines outlined in the European AI regulation reflect the need for a balanced approach, one that encourages innovation while ensuring accountability, fairness, and transparency. In conclusion, the requirements for foundation models set a high bar for trustworthiness, addressing both technical and ethical challenges. They emphasize the need for transparency, rigorous testing, and data quality management at every stage of the model lifecycle. By adhering to these guidelines, providers can ensure that foundation models are not only powerful, but also aligned with societal values and expectations. Trust in AI starts with trust in the foundations, and these requirements are a critical step toward achieving that goal. Artificial intelligence is no longer just about technological innovation. It's about building systems that people can trust. Trustworthy AI is not achieved by accident. It requires a structured, deliberate process to ensure fairness, reliability, and ethical responsibility at every stage of development. The slide outlines a systematic approach for developing AI applications that meet these high standards, focusing on risk analysis, target criteria, mitigation measures, and continuous monitoring. The first step in this journey is to define the target function and application domain. Before an AI model is trained or deployed, it is essential to specify what it is designed to do, what types of inputs it will process, and what outcomes are expected. This process ensures that the AI application is built with a clear purpose and within a well-defined operational design domain, ODD. For instance, an AI system developed for fraud detection must have a precisely outlined scope, covering the types of transactions it will analyze, the data it will use, and the decisions it will support. Without a clear target function, an AI system risks generating unreliable or unintended results. Once the scope is defined, the next step is to conduct an application-specific risk analysis. AI applications do not operate in a vacuum. They interact with real-world users, processes, and data ecosystems. This step involves identifying potential risks associated with fairness, reliability, and data protection. For example, if an AI-powered hiring tool is being developed, the risk analysis must assess whether the system could inadvertently introduce biases against certain demographics or create discriminatory hiring patterns. Addressing these risks at the design phase prevents issues from becoming embedded in the AI system. With risks identified, the development process moves toward establishing measurable target criteria. AI performance cannot be assessed without clear benchmarks. Developers must set specific goals aligned with trustworthiness dimensions such as fairness, transparency, robustness, and accuracy. These targets should be tailored to the application's domain. For example, in medical AI applications, accuracy in diagnostics and reliability under varying conditions are crucial, whereas in financial AI, explainability and fairness in decision-making may take precedence. Without well-defined success criteria, it becomes impossible to determine whether an AI system is truly trustworthy. However, setting targets alone is not enough. Implementing mitigation measures is crucial to addressing identified risks. This step involves integrating techniques such as bias filtering, rule-based constraints, and adversarial testing to strengthen AI performance. For example, an AI-driven lending system can implement fairness constraints to ensure it does not disproportionately reject loan applications from specific demographics. Similarly, filtering mechanisms can be introduced in AI chatbots to prevent the generation of misleading or harmful content. By embedding safeguards directly into the system, developers can proactively mitigate risks rather than reacting to them after deployment. The final step, and arguably the most important, is to monitor and ensure quality during operation. AI applications do not remain static. They evolve with new data, user interactions, and external conditions. Continuous monitoring ensures that AI systems maintain their integrity over time. This involves setting up mechanisms to detect performance drifts, anomalies, or unintended consequences. For example, an AI-powered recommendation engine must be regularly evaluated to ensure it does not reinforce harmful biases by overrepresenting certain types of content. Post-deployment testing and refinement are essential to keeping AI systems aligned with ethical and performance standards. Ultimately, developing trustworthy AI is a continuous process, not a one-time task. It requires careful planning, rigorous evaluation, and ongoing monitoring to ensure that AI applications serve their intended purpose without causing harm. By following these structured steps, organizations can build AI systems that not only perform well, but also earn the confidence of users, regulators, and stakeholders. In conclusion, trust in AI is not something that happens automatically. It is designed, tested, and maintained. By adopting a structured development process that prioritizes fairness, transparency, and accountability, we can ensure that AI serves as a force for positive change rather than a source of unintended harm. The future of AI depends not just on how well it performs, but on how well it aligns with the ethical principles that govern its use. Artificial intelligence is only as good as the foundation it is built on. Selecting the right foundation model is a crucial step in developing trustworthy AI applications, as the model's capabilities, limitations, and biases will directly influence the outcomes of the AI system. The process of choosing an appropriate foundation model requires careful evaluation across several key areas: technical suitability, trustworthiness dimensions, and benchmark testing. These criteria ensure that the model is not only powerful, but also aligned with ethical and operational requirements. The first step in this selection process is assessing the technical suitability of a foundation model. Different AI applications have different needs, and not all models are suitable for every use case. A model that excels in natural language processing may not perform well in image recognition, and vice versa. Developers must evaluate whether a foundation model meets the specific requirements of the intended application. This involves analyzing the model's performance metrics, reliability, and robustness, ensuring that it can handle real-world data variations effectively. For example, a legal document analysis AI must be tested on a wide range of legal texts to confirm its ability to process complex language structures accurately. Beyond technical considerations, an AI model must also align with trustworthiness dimensions such as fairness, transparency, reliability, and data protection. The slide emphasizes the importance of examining how a foundation model was trained and whether its dataset introduces biases that could lead to unfair outcomes. For instance, a hiring AI trained on historical employment data might inherit biases that favor certain demographics over others. Evaluating fairness at this stage prevents discriminatory patterns from becoming embedded in the application. Similarly, transparency is critical. If a model operates as a black box with no explainability, it becomes difficult to justify its decisions to users and regulators. To systematically assess a foundation model's suitability, benchmark testing plays a crucial role. The slide highlights standardized benchmarks such as GALU, SuperGALU, and BERT score, which provide objective measures of a model's ability across various tasks. These benchmarks help developers determine how well a model performs in areas like text classification, question answering, and fairness. By comparing multiple foundation models against these standards, organizations can make informed choices about which model best aligns with their goals. For example, if an AI application requires strong interpretability, a model with high explainability scores on standardized benchmarks would be preferable. Another critical aspect of selecting a foundation model is verifying its prior validation and alignment with industry standards. Many models are pre-trained by leading AI organizations, but not all of them meet the rigorous ethical and technical requirements needed for high-stakes applications. Developers must investigate whether a model has undergone independent audits, whether its training data has been properly documented, and whether it meets the ethical and regulatory criteria necessary for its deployment. If a model has been validated for fairness and security in prior applications, it is more likely to be a trustworthy choice. Ultimately, choosing the right foundation model is not just about performance. It is about ensuring the AI system aligns with ethical principles, legal requirements, and practical needs. A poorly selected foundation model can introduce biases, create opaque decision-making processes, or struggle to adapt to specific application domains. On the other hand, a well-selected model provides a strong, reliable, and ethical foundation for AI systems, ensuring that they serve their intended purpose while maintaining user trust. In conclusion, selecting a suitable foundation model requires a multifaceted evaluation process. It involves technical analysis, trustworthiness assessments, benchmark testing, and prior validation to ensure that the model is both capable and ethical. By carefully considering these factors, organizations can develop AI applications that not only perform effectively, but also meet the highest standards of fairness, transparency, and accountability. Trustworthy AI begins with trustworthy foundations, and this selection process is the first step toward building responsible and impactful AI systems. The foundation of any AI system is the data it learns from. Selecting the right data for both development and testing is one of the most critical steps in ensuring the reliability, fairness, and effectiveness of AI applications. The slide highlights the importance of high-quality data, emphasizing that the selection process must be strategic and thoughtful to prevent bias, ensure representativeness, and support accurate model performance. Poor data selection can lead to models that reinforce existing inequalities, generate misleading outputs, or fail to generalize to real-world conditions. One of the key challenges in data selection is that it is often resource-intensive and time-consuming, particularly for unstructured data such as text, images, and audio. Unlike structured datasets, which are organized in predefined formats, unstructured data requires significant preprocessing, annotation, and validation to be useful for AI training. In many cases, the cost of labeling data, especially for complex domains like medical imaging or legal text analysis, can be prohibitively high. As a result, organizations must be strategic in selecting which data to prioritize for training and validation. Let us also underscore the role of quality metrics for data selection. Not all data is created equal, and using the wrong dataset can compromise an AI system's fairness and reliability. 3 key metrics determine whether data is suitable for development and testing. Representativeness. Does the dataset accurately reflect the diversity of real-world scenarios? If an AI model is trained primarily on data from a specific demographic, it may not perform well for other populations. For example, an AI healthcare system trained mainly on data from urban hospitals may struggle to make accurate diagnoses for rural populations where medical conditions and access to healthcare may differ. Completeness. Is the dataset comprehensive enough to cover the full range of conditions the AI system will encounter? Incomplete datasets can lead to blind spots in AI decision-making. If a fraud detection AI is trained on transactions from only a few financial institutions, it may fail to recognize fraudulent patterns that occur in different banking environments. Freedom from bias. Does the dataset introduce or reinforce unwanted biases? AI systems learn from patterns in the data, and if the data contains biased representations, the AI will replicate and even amplify those biases. For example, historical hiring data that favors male candidates for leadership roles can result in an AI-powered recruitment system that continues to disadvantage female applicants. Bias mitigation strategies, such as diverse dataset curation, resampling techniques, and fairness-aware learning, must be implemented to ensure equitable AI outcomes. Beyond quality metrics, the slide highlights the importance of data coverage requirements. A dataset must encompass various condition scenarios and contexts to validate the AI system's effectiveness. This is particularly important during testing, where the AI's robustness and adaptability must be evaluated. Testing data should include a broad spectrum of cases, both typical and edge cases, to ensure the AI performs consistently across different real-world situations. For example, an AI used for facial recognition must be tested across different lighting conditions, facial expressions, and ethnicities to avoid performance discrepancies. Ultimately, the significance of high-quality data cannot be overstated. Data shapes how AI systems behave, what they prioritize, and how well they generalize beyond their training environment. Ensuring diverse, representative, and unbiased data selection is fundamental to building trustworthy AI systems that are fair, reliable, and transparent. In conclusion, data selection is not just a technical step, it is an ethical responsibility. The data chosen for development and testing dictates the fairness and effectiveness of AI applications. Organizations must invest in robust data governance strategies, prioritize bias detection and mitigation, and continuously refine datasets to ensure AI systems meet the highest standards of trustworthiness. As AI continues to expand into critical domains like healthcare, finance, and law, the responsibility to ensure high-quality data selection has never been more important. The future of AI depends not just on the models we build, but on the data we use to build them. Developing a powerful AI system is only half the battle. The real challenge lies in ensuring that it functions reliably, fairly, and transparently once deployed. AI models are not static. They evolve with new data, changing conditions, and unforeseen challenges. That's why rigorous testing and validation are essential to ensuring that AI applications maintain high levels of trustworthiness. The slide outlines three critical aspects of AI testing and validation: integration of test platforms, use of application-specific test data, and continuous testing throughout the AI lifecycle. Each of these plays a crucial role in evaluating AI performance, detecting potential risks, and ensuring compliance with ethical and regulatory standards. The first key component is the integration of test platforms for enhanced evaluation. AI systems require specialized testing environments where they can be systematically examined before real-world deployment. These platforms automate key validation processes, providing metrics that assess the AI's accuracy, robustness, and fairness. By using standardized evaluation tools, organizations can compare AI performance across different tasks and datasets, ensuring that models meet predefined trustworthiness benchmarks. For example, a natural language processing (NLP) model for customer service should be tested on diverse linguistic inputs to assess how well it handles accents, dialects, and industry-specific terminology. Beyond standard test platforms, the slide highlights the importance of utilizing application-specific test data rather than relying solely on generic benchmark datasets. AI models often perform well in controlled settings, but struggle when faced with the complexities of real-world applications. To address this, developers must create custom test cases tailored to the specific domain where the AI will operate. For instance, a medical AI system should be validated using real patient data with privacy safeguards in place, rather than general diagnostic datasets. This ensures that the AI is tested under conditions that closely match its intended use case, improving its reliability in practical scenarios. Continuous testing during development is another fundamental requirement for trustworthy AI. AI models must be evaluated not just before deployment, but throughout their entire life cycle. AI systems evolve as they interact with new data, meaning that biases, performance drifts, and unintended behaviors can emerge over time. To mitigate these risks, testing must be integrated into every stage of AI development, from early prompt engineering and fine-tuning to post-deployment monitoring. A sentiment analysis AI, for example, might perform well at launch, but develop undesirable biases over time as it ingests new data from social media. Regular audits, fairness checks, and explainability assessments help detect such issues early. This structured approach to testing and validation is critical for regulatory compliance. With laws like the European AI Act mandating transparency and accountability, AI providers must demonstrate that their systems meet ethical and legal standards. Testing protocols ensure that AI-generated outputs do not reinforce discrimination, violate data privacy laws, or produce harmful misinformation. Continuous validation also builds user trust. If people understand how an AI system is tested and monitored, they are more likely to rely on its decisions. In conclusion, Testing and validation are not optional steps. They are ongoing commitments. AI systems that are not rigorously tested risk becoming biased, unreliable, or even dangerous. By integrating specialized test platforms, domain-specific validation datasets, and continuous evaluation strategies, organizations can ensure that AI applications remain fair, transparent, and aligned with ethical principles. The true measure of AI's success is not just how well it performs, but how well it maintains trust over time. Artificial intelligence is not a one-time deployment. It is a living system that continuously interacts with new data, evolving conditions, and user behaviors. Even the most rigorously tested AI applications require ongoing monitoring and quality assurance to maintain their trustworthiness, accuracy, and ethical integrity over time. Without a structured approach to continuous evaluation, AI systems risk degrading in performance, reinforcing biases, or becoming vulnerable to emerging threats. We must highlight two critical aspects of AI monitoring and quality assurance: management of external dependencies, continuous testing and evaluation. These processes ensure that AI systems remain reliable, adaptable, and aligned with ethical and regulatory standards throughout their lifecycle. The first key area, management of external dependencies, focuses on the fact that AI systems do not operate in isolation. They rely on external data sources, APIs, regulatory frameworks, and evolving societal conditions. If any of these dependencies change, the AI's behavior and performance can be impacted in unexpected ways. For instance, an AI-powered financial forecasting tool may depend on real-time stock market data, but if an external data provider modifies its API or stops providing updates, the AI could begin making incorrect predictions. Similarly, an AI-driven customer service chatbot might be programmed to recognize language patterns, but shifts in slang, cultural expressions, or business policies could render its responses outdated or even inappropriate. To mitigate these risks, AI systems require robust retraining strategies that allow them to adapt to changing environments. This includes periodically updating models with fresh, high-quality training data and implementing human-in-the-loop oversight to catch errors before they impact users. By planning for these external dependencies, developers can ensure that AI applications remain resilient and continue to operate as intended. The second key focus of the slide is continuous testing and evaluation, a critical component of long-term AI quality assurance. Unlike traditional software, AI systems are probabilistic, meaning their outputs can change over time as they interact with new data. What works well at launch may drift away from desired performance levels after weeks or months of operation. To prevent this, AI applications must undergo regular post-deployment testing using meaningful performance, fairness, and transparency metrics. These evaluations help detect model drift. When an AI system's accuracy declines due to shifts in real-world data distributions, emerging biases. When an AI model begins favoring certain outcomes due to imbalances in new training data. Security vulnerabilities. When an AI model becomes susceptible to adversarial attacks or manipulations. For example, a fraud detection AI that initially works well may start producing false positives or missing fraudulent activities as financial fraud tactics evolve. Continuous testing ensures that these shifts are identified and addressed through retraining, parameter adjustments, or enhanced monitoring protocols. Beyond technical concerns, continuous testing is also essential for regulatory compliance. With AI regulations such as the European AI Act and evolving data protection laws, organizations must demonstrate that their AI systems consistently meet transparency, accountability, and fairness standards. Failing to continuously monitor AI performance can lead to legal liabilities, reputational damage, and loss of public trust. As AI becomes increasingly integrated into high-stakes domains like healthcare, law enforcement, and finance, the need for continuous monitoring will only intensify. Organizations must move beyond one-time audits and adopt automated, real-time quality assurance frameworks that keep AI systems aligned with their intended purpose. Human oversight will remain crucial. AI may be capable of automating complex tasks, but human intervention is essential to correct errors, retrain models, and ensure that AI decisions align with ethical principles. AI is not a static product, it is a dynamic system that requires continuous supervision, adaptation, and refinement. Organizations that prioritize monitoring and quality assurance will build AI systems that remain reliable, transparent, and aligned with human values. Those that neglect these processes risk deploying AI that over time becomes inaccurate, biased, or even harmful. Trust in AI is not earned once, it must be maintained over time. The key to sustainable AI success is not just in building powerful models, but in ensuring they remain trustworthy long after deployment. Artificial intelligence has evolved from a promising technology to an integral part of modern life, influencing industries, economies, and societies at an unprecedented scale. But as AI continues to expand, so do the challenges surrounding its fairness, reliability, and ethical use. Trustworthy AI is no longer just a goal, it is a necessity for ensuring AI's long-term success and acceptance. This final slide provides a summary of key takeaways and offers a vision for the future of AI governance and regulation. It emphasizes that the European AI regulation is not just about imposing legal constraints, but about fostering trust, safety, and competitive advantages for businesses that prioritize responsible AI development. The journey toward trustworthy AI is built on several core principles, each of which has been explored throughout the presentation. Trust is the foundation of AI adoption. Without transparency and accountability, users, businesses, and regulators will remain skeptical of AI systems, limiting their adoption and impact. Fairness and data quality are critical. AI is only as unbiased as the data it is trained on. Ensuring diverse, representative, and high-quality datasets is essential to preventing discrimination and unreliable outputs. Testing, validation, and continuous monitoring ensure long-term reliability. AI models evolve over time, and their performance must be consistently evaluated to prevent accuracy drift, emerging biases, and ethical concerns. Regulatory frameworks, such as the European AI Act, are shaping the future of AI governance. Organizations must prepare for increased scrutiny and compliance requirements, prioritizing explainability, risk assessments, and ethical design in AI applications. Transparency builds confidence. AI decisions must be explainable, interpretable, and aligned with ethical standards to earn user trust and regulatory approval. These takeaways reinforce a central theme. AI must be designed not just for efficiency, but for accountability and ethical responsibility. Organizations that embrace these principles will gain a competitive edge, while those that ignore them will face growing regulatory, reputational, and legal risks. Looking ahead, the implementation of the European AI regulation will create a new landscape where AI applications must demonstrate compliance, fairness, and transparency. This shift presents both challenges and opportunities for businesses and developers. Certified AI applications, the regulation will likely lead to the establishment of certification standards for AI systems, giving companies that comply with these standards a distinct advantage in the marketplace. AI applications that pass rigorous testing and validation will be trusted more than those that lack transparency. Competitive advantages for responsible AI. Companies that invest early in ethical AI practices will stand out as leaders in a landscape where trust and accountability are becoming key differentiators. AI systems that prioritize fairness, security, and user rights will attract more customers, investors, and regulatory approval. Stronger AI governance and oversight. The future of AI regulation will extend beyond Europe, with other governments and regulatory bodies adopting similar frameworks. Organizations that prepare for these changes now will be better positioned to operate in global markets. The need for continuous AI audits and compliance. AI systems will require regular audits, fairness checks, and risk assessments to ensure that they continue to align with ethical and legal standards. Organizations that treat compliance as an ongoing process rather than a one-time obligation will be more resilient in the face of evolving regulations. The discussion around trustworthy AI is not just about compliance. It is about ensuring that AI remains a positive force in society. When built with integrity, AI has the potential to drive innovation, solve global challenges, and improve lives. From healthcare diagnostics that save lives to AI-driven sustainability efforts that combat climate change, the possibilities are limitless if AI is developed responsibly. But this future will not happen by chance. It requires deliberate action from governments, businesses, and researchers. The AI of tomorrow depends on the decisions we make today. Will AI be a tool that reinforces bias and uncertainty, or will it be a trusted partner in human progress? The answer lies in our commitment to ethical AI development, transparency, and accountability. The organizations that embrace these values will define the next era of AI, one built not just on intelligence, but on trust. As we move forward, AI developers, policymakers, and business leaders must work together to ensure that AI remains a trusted, ethical, and transformative technology. The future of AI is in our hands, and the decisions we make now will determine whether it becomes a force for progress or a source of unintended consequences. Trust in AI is not just about technology, it's about the values we embed in it. Now is the time to shape the future of AI with responsibility, integrity, and a commitment to fairness.